See, this is what makes the field of programming suck sometimes. As you can see, all I wanted was to figure out how to get the status web page for PHP-FPM. And I've been working on it for 3 days now and did lots of Googling. All this could have been avoided if the documentation was not so terse. But I understand the reason why documentation is terse, because they don't want to include any material that would be dated. So I started off with this video, Status, Web Page, and Config, Part 1. Then, before I went to bed, I had to make another video because after all the trial and error I did, I finally figured out how to get the status page. Well, now I'm making the third video, and I'm trying to pick up where I left off over here. So basically, I covered from the beginning of this file. This is the configuration file for PHP-FPM. And this is the configuration for the pool www. The first thing that we learned was that we can get the status using a command line command. Service PHP 7.0 FPM status. This command is kind of like the service Apache 2 restart. So it's part of the operating system, but that's not important. What we are interested in is that when we run this command, we get the status of PHP-FPM, but it looks like this and it's in the console. What we're trying to do is we're trying to get the PHP-FPM status in a web browser. So, as the case usually is with me, I go trying to figure out one thing and I end up coming across a whole bunch of more things which are also interesting. So, while I was going over the configuration file, these are some of the things I found out. I don't want to get too abstract, but essentially this configuration file is for configuring all the PHP-FPM processes that are going to be running on my system. Here, we're allowed to specify a prefix for certain things that are going to be stored in the file system. And then we're going to be able to assign a user and a group to the processes of PHP-FPM. We get to specify which IP address and port number the PHP-FPM process listens on. Now, it's obvious why we would want to configure a port number, but to some people watching this video, they may not know that a server can have more than one network card and have more than one IP address. So here we are specifying the IP address that it listens on. And this one is referred to as the loopback. It's like a virtual network card in the computer. It doesn't actually exist on the network outside of the computer. So we're specifying where the PHP-FPM process is going to be listening. So you may be wondering, what in the hell is a listen backlog and what number should I set it to? Well, remember, this is the FPM process is listening, as we said up here. That's why we set a listen value. So it's listening somewhere. Listen backlog, it sets a limit on the number of requests that can be waiting to be listened to. And I found this in a blog post somewhere. Let me try to bring it up. It says the maximum length to which the queue of pending connections for SOC-FD may grow. If a connection request arrives when the queue is full, the client may receive an error with an indication of connection refused, or if the underlying protocol supports retransmission, the request may be ignored so that later a reattempt to add connection succeeds. It's just the requests that are waiting to be processed by PHP-FPM process. There's something called listen owner and listen group and listen mode. I believe that's there to put restrictions on who PHP-FPM can listen to. And down here, we can restrict which machine can make requests of PHP-FPM by restricting it to a specific IP address. PM stands for Process Manager, and over here we get to choose whether the Process Manager controls the number of child processes in a static way, dynamic way, or on demand. And basically the variables which we can set over here allow us to optimize our system, basically set up how many default processes should be running at a time to make best use of the processing power of our server. And then we finally get to the part about the status web page. And that should be what the rest of this video is going to be about. You see this line here? pm.statusPath equals /status. Well, this whole section up here in green is all a comment for that line. So it starts off by saying the URI to view the FPM status page. So that line is the URI to view the status page for PHP-FPM Process Manager. And as I've discovered the hard way, this URI does not work for the Apache server. It works for the FCGI protocol on this server machine. So in Apache's configuration, we have to redirect URLs that come to this expression. We have to redirect them to this same expression, but addressed by the FastCGI daemon on this machine, which is actually the process manager for FPM. I will show you that configuration, which is necessary in Apache for this to work. It's this proxy path match directive, which basically says to Apache, if you see this string, and actually this string has to match from beginning to end of the URI, then do this. And when you get the output from this, then redirect it back to the server, where we'll give it back to the client, who is the browser. It's important to understand that FCGI protocol has a daemon which responds very similarly to the way that HTTP has a daemon, which is Apache, which responds to certain requests. So what this line says is that if the server receives an HTTP request that has a URI of /status, then transparently the Apache server communicates using FastCGI. It communicates with the process manager running on port 9000, and it gives it a /status, and it knows what to do with it, because we defined /status within the process manager for PHP-FPM. It's good to have a visual of what this status page looks like, so I'm gonna go there. Okay, this is what it looks like. And it has a list of these items, which are pool process manager, listen queue, idle processes, max children reached, slow. I don't see one that says slow requests. So let's see what these things are. You can see that the pool is www. The process manager is running dynamically. Start time. Okay, start since, accept connection, list queue, max length queue. It says values are updated in real time. I wonder what that means. Okay, let's go to, I'll make another window, and I'll do a request here to see if it does anything in real time. Yeah, it doesn't refresh in real time, but once the page loads, it gives you the results at that point in time. It seems to do everything in seconds. So start since will give you the number of seconds since FPM has started. Accept connection, listen queue, the number of requests in the queue of pending connections. Max listen queue, the maximum number of requests in the queue of pending connections since FPM has started. Listen queue length, the size of the socket queue of pending connections. Okay. It says the listen queue length is 128, although we set it to 516 or something. Idle processes, active processes, total processes, max active processes, max children reached. I wonder what that is. Max children reached, the number of times that the process limit has been reached. When PM tries to start more children, works only for PM dynamic, and so it's the number of times the process limit has been reached. And we can pass query parameters. HTML full, that one is and would be good to demonstrate. Okay, so let me put it here. HTML full. Okay, so that's what it looks like. So what we're seeing is the status for each pool process. And that includes the process ID, the state of the process, whether it's idle or running. Let's see that. So this one is running, this one's idle. Start time, the number of seconds since the process has started, the number of requests the process has served. So this one served 19 requests, this one 20. The request duration in microseconds. And request method is get. Request URI. So apparently each request, okay, that's probably the last request URI because the process can be reused. So that's request URI. Request method, probably for the last request. Content length. The content length of the request, that's only with post. Content length, so it's 0. I didn't do any post requests. The user and the script. Let's see what that is. The user was not set. The main script called. Okay, those are blank. Last request. CPU. Percentage, the last request consumed. It's always 0 if the process is not in idle state, because CPU count is done when the request process is terminated. 0 for both of them. Last request memory. The max amount of memory the last request consumed, it's always 0 if the process is not in idle state. So this one, because it's in idle state, so it's telling us what it is. I noticed that when I refreshed the page, this one, which was the one that wasn't idle, became idle, and then this one became the one that's running. So that indicates to me that, well, each process can only handle one request at a time. So let's see what if I refresh again. Okay, they keep alternating. I don't know why it has to alternate. Okay. Based on fiddling around with reloading this page, and actually I also loaded a different page, I've noticed a few things. It seems that the process stays running as long as the browser which made the request has not requested a different page. So I think the process, even though the script may have finished running, maybe the connection stays open somehow between the PHP process and the browser. And that is not terminated until that browser makes a different page request. So that's something I've noticed. This video has been too long, so I'm gonna save it and upload it and then continue in a different video. All right.